Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 4 from the January 2014 International A-Level Mechanics M1 exam. This is from the Edexcel board, and this question here is about a fixed rough plane which is inclined to the horizontal at an angle of alpha, where the tangent of alpha equals 3/4. Tells us that a small box of mass m is at rest on the plane. It's at rest on the plane. A force of magnitude kmg, where k is a constant, is applied to the box. Okay, the line of action of the force is at an angle of alpha to the line of greatest slope of the plane through the box. So that angle there is also alpha. The angle that this force is being applied with the plane is alpha. Okay, then it says the coefficient of friction between the box and the plane is mu. The box is on the point of slipping up the plane, and by modeling the box as a particle, find k in terms of mu. Okay, the first thing I'm going to do is I'm going to look at this thing which says tan alpha equals 3/4. Now this, definitely in this question, what we shouldn't do is find the value of alpha, find the value of the angle. That will just make things extra complicated, because you're going to have to round it to a certain degree of accuracy, and then it will mess up our whole question. Okay, so whenever you have a question like this, what you should always try and do is think of a right angle triangle. Think of a right angle triangle where you have an angle alpha and the opposite and the adjacent side to the angle being 3 and 4. So if you just make a little right angle triangle, let me just make that a bit thinner. So if you have a right angle triangle, so we're just going to make a little drawing of a triangle that we're going to assume is right angled. Okay, then this is the right angle, and if we call this alpha, and then this would be the opposite, this would be the adjacent. Tan of alpha is 3/4 in this triangle. That's true. And in this particular triangle here, the hypotenuse would be 5. 3, 4, 5 triangle. Square root of 3 squared plus 4 squared gives us 5. So from this triangle, we can work out the exact value of the sine of alpha, which is the opposite over the hypotenuse, which is 3/5, and the exact value of the cosine of alpha, which is adjacent over the hypotenuse, which is equal to 4/5. So we know that we're going to have to be using sine and cosine alpha in our working later on, and having that as an exact value will help us to keep things exact and not have to do with decimals and stuff like that. So I think that's the way to go in this type of question. Always write out the value of the sine of the angle and the cosine of the angle, rather than finding the value of the angle itself. So inverse tan of alpha equals. This is way better to do that, and a lot of these questions are designed in that way. That's why they give you this angle in such a format like this. Okay, they could have put 0.75. They're making it easy for you here to be able to do this. All right, that's the first thing. That's the first thing sorted out. So now I'm going to write here. I've got everything written down here as well. I've got the diagram here because I don't have to keep going up and down. So I'll write down here that sine alpha is 3/5 and cosine alpha is 4/5. So I'll write that here. Sine alpha is 3/5 and cosine of alpha is equal to 4/5. Okay, so that's something that we got sorted out. Now, what I'm going to do is I'm going to make a very clear diagram showing all the forces acting upon this box. First, I'm just going to show all the main forces acting on this box. And we know that the forces acting on the box are its weight. It's the most obvious thing. And they told us that the mass of the box is m, so its weight is going to be given by mg. So mg newtons is its weight. Then you have also the reaction force between the box and the plane on which it is resting. And the reaction force is always perpendicular to the surface. So we call that R, that's the reaction force. Now, we also know that this is on the point of slipping up this rough, or sliding up this rough plane. Okay, it's about to slide up the plane, basically, going upwards. Now, if it's about to go upwards, what's stopping it from going upwards? Well, it's the friction, as well as, of course, the weight. But the friction is going to be acting in this direction. Okay, the friction is going to also be acting in this direction. Okay, that's the friction. And as it's on the point of slipping, it's very important to understand. When it says on the point of slipping up the plane, that means if you increase the force pulling it any more, then it's going to slip up. So friction has reached its maximum possible value. The frictional force just normally opposes the force that's trying to move the object. And if that force is less, the friction will be less. If that force is zero, that the friction will be zero. If, however, the force increases so much that it gets to a level which the frictional force cannot increase to match it, then it will slide. So this is on the point of slipping up the plane, meaning the frictional force has reached its maximum value. And we know that F max, the maximum value of friction in a situation, is given by mu times R, where mu is the coefficient of friction. Okay, so those are the forces acting on this object. Now what we're going to do is we are going to resolve these forces in the direction which is parallel and perpendicular to the plane. Now the friction and the reaction force are already parallel and perpendicular to the plane. That's not a problem. What we're going to do is resolve these forces, the weight and this kmg, parallel and perpendicular to the plane, because you should always resolve them in the direction of motion and perpendicular to the direction of motion. So in the direction of motion, mg will have a component going down the plane. The weight will have a component going down the plane, and also it'll have a component which is perpendicular to the plane into the plane. Okay, and kmg, this force which is holding this thing up, or trying to move it, is going to have a component which is parallel to the plane up the plane, and also it'll have a component of the plane. It will have a component which is perpendicular to the plane, acting upwards like this. Okay, I'll draw this a bit longer so I have space to write down what I need to write down. So that's okay. Now, if we consider this, I know this angle is alpha, so I can say that if I want to resolve this force in this direction here, okay, then we have to go into the angle. So this is going to be kmg times, if you're going into the angle, always use cosine alpha. And here, to resolve this force in that direction, we have to go away from the angle given. So that will be kmg times sine alpha. When you go into the angle, you always use cosine. When you go away from the angle, you always use sine. Now, what is the reason for that? Now, some students were asking that on the comments. They want to know the reason for that, okay, which I've explained in some videos, but just again, I'll explain it. Okay. Now, if you think about resolving this force in the direction over here, then basically what we're doing is we've got this triangle, which is a right angle triangle. That's what we're actually using here. We're using this right angle triangle. Okay, this is kmg on the hypotenuse, and we want to find the force resolved in this direction, which is the adjacent side. So we're going to use cosine. We can say cosine alpha equals what we're trying to find divided by kmg. Okay, so like x over kmg equals cosine alpha, so x equals kmg cosine alpha. That will be this force. And if we're resolving in the direction which is going away from the angle, it's like this angle, this direction over here. Okay, kmg in this direction over here, then we can kind of think of it as we're looking at this component which is kind of over here, which is like the opposite. It's going in this direction. So it's the opposite. So we can say the sine of alpha equals x over kmg. That means x equals kmg times the sine of alpha. So that's like some reasoning behind that. Okay, so that's for this force. We also have the weight, which is resolved in these two directions. Now, again, students asking, we know this angle is alpha. Now, how do we know this angle is alpha? Okay, well, it's always the same angle as the angle of the incline of the plane over here between the weight and the perpendicular line from the plane, like this. Now, why is that? I've explained it in some other videos, but I'll just explain it again. It's due to the fact that we have a pair of what I call similar triangles, which I'll try to illustrate to you. Now, I have this triangle over here, there's one triangle over here, which I'll try to, let me just get that sorted out. Okay, so we have the triangle over here. Okay, this is a triangle, and we have a triangle that's over here. Now, what I'm going to do is I'm going to mark, for example, this is in this triangle 90 degrees over here. That's 90 degrees in this big triangle. So I'm going to take that out here. That I'm going to mark this as 90 degrees. That's 90 degrees over here. And this small triangle here, this is also 90 degrees over here, down here. Okay, this is 90 degrees down here. So this is also 90 degrees. So I'm also going to mark that in this small triangle here. That's 90 degrees. Okay, and the other thing I can see in these two triangles is that this angle is the same in both of them. This angle is on the same corner as this one. This is that corner. And it's the same corner as this one. It's the same corner. So this angle here, in this triangle, that angle there, in this triangle are the same. Okay, so I can also say about these two triangles that this angle and this angle are the same. So I can say by similarity that this angle therefore must be the same as this angle. Because if two of the angles are the same, the third must be the same. So that's the reason why this angle here is alpha. Okay, that's the logic behind it for those of you who are wondering why that's the case. So hopefully that was clear. All right, so I'll just get rid of some of these things here now. So this angle is alpha. You don't have to prove it like I just did now, but it's just for those who are curious. A lot of people asking, why is that alpha? Well, that is why it's alpha. Hopefully that's clear now. All right, so now, again, I want to now resolve this force mg perpendicular to the plane. I have to go into the angle. It's like I'm finding the adjacent side, so I'm going to be using mg times cosine of alpha. And I want to resolve it going away from the angle. So I'm looking for this, basically this direction here, which is like the opposite to the angle, which is mg times sine alpha. When you go away from the angle, you use sine. Into the angle, you use cosine. Okay, that's a nice, easy way to remember it. So now we have all the forces acting on this particle shown. Okay, so we have all of them shown. Okay, so now we can resolve the forces parallel and perpendicular to the plane. You always resolve them parallel and perpendicular to the motion or the motion that's occurring or the motion that's about to occur. Okay, it would occur, the motion would occur parallel to the plane. So we resolve the forces in those two directions. So let's start with perpendicular to the plane. I have r plus kmg sine alpha. So I have r plus k times mg times sine alpha is equal to mg cosine alpha. Cosine alpha. And if we resolve perpendicular or parallel to the plane, it's about to slip up, so I'll take up as positive. I have kmg cosine alpha. Kmg cosine alpha. So I'm taking up the plane as positive. Is equal to, because it's in equilibrium still, it's not moving, it's in equilibrium, so the forces in this direction and that direction will be equal. You've got mg sine alpha, which is a component of the weight, plus the maximum value of friction Fm. Okay, so from here, what I can say is R is equal to mg cosine alpha minus k mg sine alpha. And from here, I can say F max is equal to k mg cosine alpha minus mg sine alpha. All right, so let me take these and simplify them a little bit, because I know that, for example, R is equal to, I know cosine alpha is 4/5, so this is going to be 4/5 mg minus, and sine alpha is 3/5, so that's going to be 3/5 times k mg. Be very careful not to forget the k that's there. All right, so that's R, and F max is going to be equal to, if we just do the same thing, we know the cosine of alpha, as we said, is 4/5, so that's going to be 4/5 times k mg minus, and sine of alpha is 3/5, so it's 3/5 times mg. So I can say that r is equal to, if I take out the common factor, which is mg over 5, mg divided by 5 times 4 minus 3k. And we can say f max, if I take out the common factor, I want to simplify this a bit. I've got, again, mg over 5 is common. So I have mg over 5 is common. And here I'm going to have 4k minus 3. Now what we know is that the friction, the maximum value of the friction is equal to mu times r. So therefore we can say mu is equal to F max divided by r. So it's going to be this divided by that. So you're going to have here mu is going to be equal to mg over 5 times 4k minus 3 divided by mg over 5 times 4 minus 3k. So those cancel out. So we got mu equals 4k minus 3 over 4 minus 3k. Okay, now the question tells us to find k in terms of mu. So we have to find k in terms of mu, which means we have to make k the subject. So we have to rearrange this to make k the subject. So I'll use space on the next page and we will continue there. Okay, so we want to make k the subject because the question says find k in terms of mu. So what I'll do is I'll first multiply both sides by 4 minus 3k. So I'll have 4 minus 3k, that's times mu, is equal to 4k minus 3. So I'll expand this bracket, it gives me 4 times mu minus 3k times mu equals 4k minus 3. Now we want to put k as a subject, so we'll bring the k's together on one side. So that you've got 4k minus 3k times mu on one side. On this side you've got 4 mu plus 3. Okay, so now we can take out the k as common. You got k and you got 4 minus 3 mu on this side. In fact, that's going to be plus. Sorry. Let's do that again. That was a silly mistake. Let me just fix that. So as I said, this is going to be 4k plus 3k times mu. And this is 4 mu plus 3. Okay, so you have to add 3k mu on both sides and you have to add 3 on both sides. Then we can take out k as common on this side. So you got k times 4 plus 3 mu. And on this side you got 4 mu plus 3. So we can divide both sides by 4 plus 3 mu. So you have k equals 4 mu plus 3 over, and here you have 3 mu plus 4, or 4 plus 3 mu. So that's the value of k in terms of mu. Okay, so here we don't find the actual values, numbers. It's in terms of k and mu the answer, which sometimes for some students makes it a bit more complicated. You have to do this algebraic manipulation, but we need to know how to do that. And that's one of the reasons, like in a question like this, you should leave the alpha in terms of the sine of alpha and the cosine of alpha as exact fractions. That made life a lot easier for us. So that's how you deal with such a question like this, number 4, from the January 2014 exam, from the International A-Level M1. Other questions from this paper will be found on this playlist that should be, or in this playlist that should be appearing in this area at the end of the video. Other questions about this topic, which is to do with, statics, will be found in this playlist over here. And you can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.